in this video, we'll be treating more on circular motion, and again, we are going to solve some of the examples on circular motion, and also we are going to take some possible exam questions on circular motion. Please take it. But before that, let's define what circular motion is. This right? Let's take some here. This right? Circular motion can be defined as the motion of an object. Circular motion can be defined as the motion of an object in a circle or circular path. The motion of an object in a circle or circular path. Okay, a path I'm defining is this. That is this technique. Alright? Now, what does it mean here? Let's first understand the pictorial explanation here. Now, if I'm saying about circular path here, this explains more about circular motion. Something like this. Please take note. And I'm going to have a dot here. Please take note. This is my theta. Alright? Now, this object here is going in a circular path, that is in a circular form. So if this object is going in a circular form here, what are the attributes, what are the characteristics of this object here? Okay, now please write basic characteristics of circular motion. Please take down basic characteristics of circular motion. Number one, basic characteristics of circular motion. Number one, the speed is constant. Alright, now let's use this to explain. Now, if you look over here, the speed is this here, there is no change of direction here. So the speed remains the same. Please take note. The speed is constant. Please take note. Now let's take the next one here, number two. The velocity changes. Please take note. Number two, the velocity changes. That the velocity is what? Variable. Okay? Now, what does it mean here? It means that if I have this to be in this form, we can have our velocity to be this. We can have our velocity to be this. So it changes, it shows the direction. So the velocity changes depending on the direction. I can also have our velocity to be this. Please take note. Alright? Now, this velocity changes here because this is what? Vector quantity. So the velocity here is not going to be the velocity here, the same thing here. But the speed remains the same. Okay? Now let's get the next one here. Number three, it has centripetal acceleration. Number three, it has centripetal acceleration. Please take note. Now listen. Now for this to be in a circular path here, for this to be kept in a circular path here, it means that there must be an acceleration that will be involved. And what is that acceleration? Centripetal force or what? Centripetal acceleration. Please take note. Number four, lastly, it has centripetal force. Okay? Now, for this to be inward, to be kept inward here, okay, to maintain its shape, at that point, the force needed is what? Centripetal force, please take it. Alright? Okay? Now, let's try to. Okay? Now, we have considered the basic characteristics of circular motion here, class. Now, let's try to deal on the formulas relating to circular motion. Okay, example formula 1. Formulas relating to circular motion. Formulas relating to circular motion. Alright, okay, let's treat some formulas relating to circular motion here. Okay, now the first formula here, first of all, let's use this as an example here. The first formula here is the formula relating linear velocity towards circular velocity, that is called linear speed. Okay. Now, how do we divide this? There is a formula we call length of an arc, and that formula is said to be L here is equal to theta over what? 360 times what? 2 pi r. Please take note. Alright. Now, in terms of circular here, we don't use degree to measure our angle here. In terms of circular, we use what? Radian. So this can be converted to radian. Okay, but before then, we have to know the relationship between revolution to degree, and we also have to know the relation between degree to what? Revolution. Please take it. Before we convert this guy here to radian. Please take it. That one ref means one circle. One circle in terms of angle. This circle here, angle in a circle is what's class 360 degree. It's said to be 360 degree. Now this is the relationship between revolution, that is the circle, and what? And angle. Please take it. Now let's go to the next one here. Now what is the relationship between the angle here and radian? We said that 2 pi rad is the same thing as what? 360 degree. So these are the relationship between revolution to degree, rad to degree, and finally the same thing as 1 ref is the same thing as what? 2 pi rad. So this is the relationship. So let's convert this down here from degree to rad. So this is going to be L here equal to theta over 2 pi. That means I'm replacing this down here, 360 to what? Radian, times 2 pi r. Alright? Now this guy can cancel this guy here. That means our L here we say to be theta of what? R. Please take it. So class, I want to get my velocity. If I have a parameter at distance and I want to get velocity here, because our intention is to get velocity here. If I have displacement or distance, how can I get velocity at that point? So it's just like I will divide that displacement by one time. So if this guy is displacement here, that this area is representing displacement, how do I get velocity here? I will divide by one time. So in terms of equation, anything you apply here also applies here. So divide both by t. That is time. Please take note. Divide both by t. Then this will be L over t. So apply the same thing here. It's equal to theta of r over what? T. Please take note. What does it mean here? It means that this is displacement over time here. This will give us what? Velocity. Right? Now, the next thing here is to get this down here. We don't have anything like radius over time. We have something as change in displacement over change in time. So what is that? Angular velocity. This is displacement, angular displacement. This one time. Change in angular displacement. This is displacement here. This one acts as displacement. Over time is what? Angular velocity. So this is going to be, our first formula will be V as this one here, ignore velocity here, is equal to angular velocity over time. So angular distance over time because what? Angular velocity. So this will be omega of what? R. Alright, now let's consider the next formula here in terms of circular motion. What's the next formula here? If I from this first formula here I can get second, please take it. If I have this to be V to equal to plus omega R like this, what will I do here to get acceleration here? If I have velocity, what am I going to do here to get acceleration? I'll divide by what? Time. So divide by time t, that is time. This is going to be V over t is equal to omega r over what? This plus t. Now let's try to know this. Class, velocity over time will give us what? Acceleration, right? So this will give us acceleration is equal to class. This one is said to be angular velocity over what? Time give us what? Angular what? Acceleration. And we use alpha to represent angular acceleration of what? R. Please take note. Now we call this guy here tangential what? acceleration. Please take note. So our next formula is going to be A is equal to alpha r. This is said to be tangential acceleration. Alright, but take note of this, that the formula for tangential acceleration is not the same thing as what? Linear acceleration. Now, what is the formula for linear acceleration? Said to be what? A is equal to omega squared r. Please take note. This is said to be linear acceleration. So lastly, let's take the last formula in terms of circular motion here. That is formulas related to circular motion. Before we solve the equation here, okay? Now, formula 4. Let's take formula 4 here. That is formula 4. Centripetal force. Please take note. Now, what the formula for centripetal force is said to be F is equal to mv squared over what? R. Please take note. Alright? Now, if you can know centripetal force, you can easily know centripetal acceleration. Now, comparing this guy here, listen to this. Comparing this guy here with linear force. Comparing this centripetal force with linear force, we can know the position of what? Acceleration. Now, I have this to be F to be equal to NA. This is force, compare with it, this is force. This is mass, this is mass. It means that this guy here, that the coefficient of mass, is giving us what is class? Acceleration, right? So it means that our centripetal acceleration here will be said to be A is equal to V squared over what? R. Please take it. Alright? Now we have treated all the formulas relating to circular motion here. Let's solve some questions on formulas relating to circular motion. Okay? Alright? Let's take example 1 here. A body of mass, example 1 please. A body of mass 200 gram. A body of mass 200 gram moves in a circular path. A body of mass 200 gram moves in a circular path with radius of. A body of mass 200 gram moves in a circular path with radius of 10 meters with a constant speed of 4.0 meter per second. With a constant speed of 4.0 meter per second. What is the centripetal force? They say A 3.2 newtons, B 3.8 newtons, C 4.5 newtons, D 2.0 newtons. Alright? Okay? Now, let's solve this question here. First of all, we capture a particular statement, and that statement is said to be centripetal force. Alright? Now, let's write the formula for centripetal force. The formula is said to be F is equal to mv squared over what? R. Okay? Now, let's know if definitely the given parameters are complete. If mass is given to us here, if V is given to us here, if R is given to us here. This is always what you have to do in physics. First of all, capture what you are asked to calculate. The next thing is to list out the given parameters. If there is any condition, you can obey the condition. Please take note. Okay? Now, the mass given to us there, please take note of this, is said to be 200 grams. And in physics, we don't use gram to calculate, we use what? Kg. That is the SI unit for what? Mass. So converting this guy from gram to kg, I'll divide by what? 1000. Divide this guy by 1000, we are going to have 0.2 kg. Please take note. Alright? Now the next thing given to us there, what is the next thing given to us there? The velocity given to us there is what? What's our V there? 4.0. Please take note, the same as 4. That is 4.0 meter per second. Alright? Now, the next thing given to us there is said to be radius. Our radius here is said to be 10 meters. Please take note. So it means that all the parameters here are said to be complete. So the next thing I'm going to do here is to replace them. Please take note. Alright? Replacing this, I will have our F to be equal to plus. Mass is 0.2 times. Our velocity is said to be 4 over what? That is 4 all squared. Don't forget. Over what? 10. Alright? Now 4 all squared gives us 16. Please take note of this. That is 0.2 times 16 over what? 10. Alright? This line here will give us 3.2. Alright? So this will give us 3.2 over what? 10. Okay? Now 3.2 over 10 is going to give us 0.32. So our F here is said to be 0.32 newtons. Okay? So it means that the option, there is no option for this question here. So you can just write no option, or you capture E to put down this to tell the marker that okay, there is a mistake in this question. Please be aware of this. Okay. Now let's solve the next question relating to formulas on circular motion. Let's take example 2 here. Example 2, please. An object of weight 150 newtons. Example 2, please. An object of weight 150 newtons moves with a speed of 4.5 meter per second. An object of weight 150 newtons moves with a speed of 4.5 meter per second in a circular path of radius 3 meters. In a circular path of radius 3 meters. Calculate its centripetal acceleration and calculate its centripetal acceleration and the magnitude of the centripetal force. Calculate its centripetal acceleration and the magnitude of the centripetal force. Alright? Now let's solve this question first. And I told you guys earlier before that whenever you want to approach any question on physics, you capture what you are asked to calculate, you list out the parameters. If there's any condition, you obey that condition. Please take it. Alright? Now let's solve this. Alright, we are asked to find centripetal acceleration, and the formula is said to be A is equal to V squared over what? R. Please take note. You can use either small letter or calculator to show acceleration. So let's see what is given to us there. Now the given parameters here is said to be weight, that is W, is said to be 150 newtons. Please take note. What again? The radius here is given to us as what? 3 meters. Please take note. What again, please? Given to us? Speed. Okay. Now our speed or velocity is given to us as what, please? That is 4.5 meter per second. Alright? Now class, if you look over here, our velocity is given, our radius is given. So we can easily replace the parameters here, right? To find this. So our acceleration here is said to be class 4.5 all squared over 3. Okay? Now let's point our calculator here. 4.5 all squared. Let's get the answer here. Let's get the answer for 4.5. Alright, now replacing this, we have 4.5 all squared divided by 3. Alright, now point your calculator. 4.5 all squared divided by 3. I will have our answer to be equal to 6.75 meter per second squared. Please take it. Alright, we have solved for our centripetal acceleration here. Remember, we also asked to solve for centripetal force. Okay, now remember we always replace our parameters depending on what is given to us and depending on the parameters in the formula. Please take note. Okay, now first of all, since we are asked to calculate centripetal force, class, what is the formula for centripetal force? Is said to be F is equal to NV squared over what? Please take note. And our mass here is not given to us here. Please take note. But our velocity is given to us, our radius is given to us. Where can we get mass here? But remember that weight is said to be mg. Please take note. Alright? Now, if weight is said to be mg here, we can easily calculate our mass. But the question now is, whenever, listen to me, whenever g is not given to us, what aspect of g can we use to get the accurate answer here? Now, this is what you should understand here. Whenever the value of g is not given to us, g is a constant value. This statement, we all know it as 9.81 or what? 10. So the question now is, whenever it's not given to us, which of the value am I going to use? Is it 9.81 or 10? So whenever g is not given to you and you want to use g, the g you are going to use is the approximated value of g, which is what? 10 meters per second squared. So our g we are going to use here will be 10 meters per second squared. Please take note of this. Please take note. Alright? Now replacing this is going to be, weight is already given to us as what? 150 is equal to, what is our mass there? It's not given to us, times 10. So making mass the subject, the mass here will equal to 150 divided by 10. What is the answer? 15 kg. It means that the mass now is now given to us here. We can easily calculate for what? Centripetal force. So our force here, the force here will equal to plus 15 times V. What is our V at this point here? 4.5 all squared divided by, what's our radius here, please? 3. Please. Alright, let's point to our calculator here. First of all, 4.5 all squared times 15 divided by 3. This will equal to 101.25 newtons. Alright, in our part 2 for circular motion, we'll be treating the analogy between circular motion and linear motion. And again, we are going to treat the equation of circular motion, which you guys are going to see in your exam. So all you just have to do here is to subscribe to the channel and get notified when the video is being posted. Okay, thanks so much.